My name is Bill Lavolia, and I'm doing a presentation on steel piles. Steel as a material has many advantages. One advantage is its average resistance factor is anywhere from 260 to 6,500 kips. This is very strong when comparing it to other materials, one being concrete, which has a resistance factor of up to 3,000 kips. If you look at wood piles have up to 120 kips. Steel H piles are also great for deadlines because they minimize pause and delay times in construction. In many cases, eliminate it altogether. They can be ordered in standard sizes, hauled, and simply attached on site while they're being driven in the ground. Another advantage of steel piles is its ability to reach depths of up to 200 feet. Concrete piles can reach depths of 150 feet, and wood piles can reach depths of up to 120 feet. A disadvantage of steel piles would include corrosion, which is the reduction of the cross-sectional area of the pile. This can be prevented by the use of corrosion-resistant steels, increasing the cross-sectional area of your pile, or with the use of galvanized coatings. Other disadvantages include expensive upfront costs and deflection of the steel pile when driven near the edge of a bearing surface. There are two different types of piles. One pile is the bearing pile that accepts the forces from the building and transfers them to the rock bed below. Both replacement and displacement piles can be used as a bearing pile. Friction piles are piles that transfer the forces from the building to the soil below. When using friction piles as displacement piles, this is often done in soft soils. Replacement piles are used for the harder soils. There are many different shapes of steel piles, including H-sections, hollow, and pipe. Pipe piles can be described as filled or unfilled, and then open-ended or close-ended. The H-section is a versatile and widely used pile, with the factored resistance of up to 2,500 kips. It is a replacement pile, having low impacts on soil and leaving the surrounding soil undisturbed. It does this with little to no vibration, causing no effect for surrounding structure. It performs well being driven into dense, hard soils, also having the ability to break through boulders and reaching depths of up to 200 feet. It does this with around 50 blows per 300 millimeters, while the concrete piles take around 175 blows per 300 millimeters. This saves you time per pile and increasing your productivity. H-piles are used in many projects. They are widely used for industrial foundations, retaining wall design, apartment building foundation, and bridge foundations. Pipe piles are replacement piles that have a factored resistance of up to 6,500 kips. They can reach depths of 200 feet and are best in hard soils when it is used as a friction pile. The pipe pile also has no weak axis, which means that you can load it the same way in one direction as you can the other. Closed pipe piles are displacement piles, which function perfectly as a friction pile in softer soils. Often this steel pile can be filled with an adequate amount of concrete to increase the bearing capacity. This pile has a resistance of up to 2,500 kips and can have a depth reaching 200 feet. This pile also has no weak axis. pipe piles are best suited for industrial foundation, marine foundation, river bridge piles, fender systems, piling walls, and windmills. Hollow sections, otherwise known as box piles, have high column buckling strengths. This buckling strength helps in marine applications. The box pile is a replacement pile which is best in soft soils when it is used as a friction pile. Hollow box piles are best suited for industrial foundation, marine foundation, wall pilings, and more. Pile foundations are this nation's backbone, and choosing the correct steel pile can vary upon what soil conditions are surrounding the project.